This video is focusing on series and summation notation. Sequences were just a list of numbers. They could be finite or infinite, meaning that they had a set number or they continued on forever. Same with series. It's just now, instead of doing a number, comma, a number, we are adding the terms together. So they also could be finite, where we add a certain amount and we can actually find what the total is by adding them together. Or there could be infinite, where it appears to be a list of numbers that are being added together and they're going to continue going on. So here we cannot find a final answer or a final sum because we could keep adding and adding and adding on forever. Summation notation is what we use to write series. For example, you can see this list that I have here. Now, the domain, it's still the same. Assume it's 1 unless I tell you otherwise. So it's 1, 2, 3, 4, 5. So starting at 1, all the way to the 5th position, so I have 5 terms. And then I put the I equals 1. This could also be n, really any variable, but your variable equals 1. That's our starting point for the domain. And up here is our ending point for the domain. So positions 1 through 5. And then here we write the rule. So the rule happened to be that in order to get from the domain to the range, we had to multiply the domain by 3, because 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, so on and so forth. So I put that rule there. Make sure your variable matches, and we'll work with this here soon. Right here is just giving you some more vocab. There is a typo right here. It should say where I is the index of summation, so we call this right here our index, or I just call it my starting point. It is the lower limit of the summation, and then here is our upper limit. So we have our lower limit and our upper limit of the summation. So I'll just put lower, upper, and then our rule. We read this as the sum from I equals 1 to 5 of 3i. So we say the sum, summation means the sum, from the lower limit, I equals 1, to 5 of your rule. Summation notation for an infinite series would also have the rule, our lower limit, but it would not have an upper limit, so we'll just put infinity because we keep adding on. So it's basically the exact same thing, except the upper is infinity. So what we're going to do is we're going to practice writing summation notation. We're not actually going to solve or add. I'm just practicing writing. For summation notation, I'm going to start with my E, which means I am finding the sum from, let's put our lower limit. So I'm just going to always have you start off at 1. So I equals 1. All the way to, here's a finite series. There are 1, 2, 3, 4, 5 terms. So it's going to go all the way up to 5. That's my upper limit. And then over here on the right-hand side of the summation symbol, I need to put the rule. So remember, to get the rule, we look at the domain and ask how we get the range. Well, this is actually the same as the example we did before. It's 3i. For B, we have the summation from starting at 1. We have 1, 2, 3, 4, 5, 6 terms. I'm going to put a 6 up top for my upper limit. And now I need to write the rule. Notice how it is alternating between positive and negative. So when we looked at rules before, I told you that we're either going to use -1 to the n or -1 to the n plus 1. So let's see if -1 to the n will work. If I plug in my domain of 1, that'd be -1 to the first power, and that is a -1. So it does start with a negative, meaning that is what I'd want to use. If the 2 would have been positive, I would have had to use n plus 1, because 1 plus 1 would have given me 2, and -1 squared is a positive 1. So this right here only took care of the alternating signs. I haven't actually written the rule yet for the terms. How does 1 become 2, 2 become 4, 3 becomes 6? Well, it appears that each time we're just multiplying n, well, excuse me, I have to be consistent. So multiplying, I used I. Oops, I'm going to have to fix that. Multiplying I by 2. If you wanted to use n, since we typically used a sub n, we could. We would just have to make this an n right here. All right, C, we have our summation. We're starting at 1. And then notice how it says plus dot dot dot. So that means its upper limit will be infinity because it's an infinite series. And then we're just going to write the rule in terms of I, or whatever variable you used here. Looking at these terms, I see that it always has a 2 in the numerator. And if the domain is 1, 2, 3, 4, 5, I need to see how I could get that denominator. Well, notice how all of these are perfect squares. 4, 9, 16, 25, 36. So they're all perfect squares. It's just not the perfect square of the domain. So this is 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. So it looks like we're going to have to do not I squared, but I plus 1 squared. Notice how then I'd have 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. All right, D. Once again, summation, starting at 1. It's infinite, so going to infinity. We just need to write the rule using the domain. 1, 2, 3, 4, 5, 6. Now, taking a look at this, asking myself how I can use the domain to get the range, I see that, now at first you might think, oh, just multiply it by 2, because 1 times 2 is 2, 2 times 2 is 4, but 2 times 3 would have been 6. So 2 times I would not work. However, 2 to the power of I would. 2 to the first power is 2. 2 squared is 4. 2 cubed is 8. There we go. 2 to the fourth is 16, so on and so forth. So it should have been 2 to the power of I. We are now going to expand each series and evaluate them. So here's where you may see that we're starting somewhere other than 1. So make sure you pay attention. This time, instead of using I used K, just to show you there is different ways that you could be writing this. So starting at 3 means I start plugging in at 3. So I'm going to put my first term, 1 over 2 cubed, plus, because it's summation, that's 3. Now it's time for 4. So 1 over 2 to the 4. Keep going till we get to 6. Plus 1 over 2 to the 5th, plus 1 over 2 to the 6th. So you can see here, I used my rule. I started plugging in at 3, and I kept going until I got to the upper limit of 6. I'm going to clean this up a little bit. It's 1 over 2 cubed is 8. 1 over 2 to the 4th is 16, and I'm just going to keep cleaning this up so it's easier to plug into my calculator. 1 over 2 to the 5th is 32, plus 1 over 2 to the 6th, which is 64. So just plug this all in your calculator. Either use the fraction tool or use parentheses. So parentheses 1 divided by 8, close your parentheses, then add. But after you try it, you should end up with 15 over 64. Or if you plugged it in your calculator and got a decimal, that's 0.234. All right, part B, we have the summation starting at 1, ending at 4. So what we're going to do once again is we're just going to start at 1. So we plug it into our rule. and then keep going all the way till we get to 4. So that was 1. Here's 2, 3, 4. So I'm going to stop after 4. And we're adding all of these together. So now what I really have here is 10 minus 1 squared is 1, plus 10 minus 2 squared, which is 4, plus 10 minus 3 squared, which is 9, plus 10 minus 4 squared, which is 16. So those squares only belonged to the, oh, sorry, I didn't realize you couldn't see it. Those squares only belong to the numbers in the second term of the parentheses. Going to keep cleaning it up. 10 minus 1 is 9, plus 10 minus 4 is 6, plus 10 minus 9 is 1, plus 10 minus 16 is a negative 6. So you could either put plus negative 6 or just minus 6. If you plug that in your calculator, or you can see the 6's cancel, you're left with 10. If you feel comfortable, you can go ahead and try C and D on your own. Otherwise, just stick with me and I'll work through these. Once again, using the rule, we're starting at 1 and ending at 4. So here's 1, 2, and I'm just substituting it into the rule, 3, 4. Cleaning it up, always clean up your parentheses. It'll make it so much easier. So 2 times 1 is 2 minus 1. Plus 2 times 2 is 4 minus 1. 2 times 3 is 6 minus 1. Plus 2 times 4 is 8 minus 1. So really what we have here is 1 plus 3 plus 5 plus 7. And then you're going to add them all together. You'll end up with 16. Part D, we have the summation. This looks a little bit more challenging, and that's okay. Remember, it's still the same thing. Here's our lower limit, here's our upper limit. So starting with 1, I'm just going to plug it in. Negative 5 times 2 to the 1 minus 1 plus negative 5. I'm going to put parentheses around it. Or just keep in mind, if you have a plus and a negative, that becomes a negative, so subtraction. Up to you how you want to write that. And then now I'm doing 2's, 3, I'm running out of space, I'll bring it down, 4, and 5. So really what I have here is negative 5 times 2 to the 0 power, which is 1, plus negative 5 times 2 to the first power, which is 2, plus negative 5 times 2 to the second power, which is 4, plus, I'm going to bring it down, negative 5 times 2 cubed, which is 8, plus negative 5 times 2 to the fourth, which is 16. So this becomes negative 5 times 1, which is negative 5, plus a negative 10, so minus 10, plus a negative 20, so minus 20, plus a negative 40, so minus 40, and plus a 5 times 16, I believe that's 80, so minus 80. Combine those, you get negative 155. So that one was a little bit more difficult to go through. At this point in time, I'd like you to begin the homework and then upload a picture to Google Classroom when you're done.